In the initial top view of the solder pot, we can see the general layout of the solder pot. Pump shafts are located in the rear of the solder pot. Unique to the VS system are the gutter channels that are located between the main wave and the chip wave nozzle and at the exit point of the main wave. These two gutters act as a U-shaped channel that take all the solder coming from the waves and divert all the solder to the front operator side of the solder pumps. This unique design provides a number of key advantages in the management of dross and operational functions as it relates to required preventive maintenance. The dross management's design and complemented gutters divert the solder and provide three key advantageous aspects due to the design. Number 1. With the solder being diverted away to the front of the solder pot, the recirculation prevents the solder dross mixture between the waves having direct access to the recirculation draw of the pumps. The gutters provide time to separate the dross from the solder, allowing time for the dross to float to the top of the dross containment area on the front of the system. This in turn minimizes the dross solder mixture from being pulled into the solder pumps, keeping the lower cavity consistent in size and volume by not getting contaminated with dross pulled in by the pumps. This allows the users consistent RPM and solder wave height, along with prolonging required preventive maintenance to 2,000-hour cycles and beyond. Number 2. Due to the dross being channeled into one location, the removal of dross from the system is simplified. The dross can be removed without the need to remove the solder pot out of the rear of the system on a daily basis. This in turn provides decreased downtime to de-dross the system. And number 3. Due to the nature of the design, allows the solder waves to be positioned extremely close to each other, helping in thermal loss with lead-free applications. Furthermore, the design of the narrow solder pot allows the wave hardware to be placed lower in the solder pot in comparison to traditional solder pots. Due to the wave hardware location and fall distance of the solder that is being pumped, there is considerably less dross being formed due to this design. Additionally, the center gutters have an adjustable choke that restricts the solder flowing from the gutter to the dross collection area. This choke allows the solder falling distance to be further decreased, reducing further the dross being produced. In this next overview of the animation, we can witness the solder wave flowing and the solder dross mixture being returned to the dross collection area in the front of the solder pot. You can also see the choke plate located at the end of the gutter that is between the two waves, and you can get an understanding of the solder flow to the dross collection area. In this exit end view, you can visualize the solder dross mixture entering into the dross collection area at the front of the solder pot, the left side. You can see the dross management area and the physical walls used to contain the dross and filter the returning solder flow in the removable grate. The red and green arrows outline the flow of the solder returning to the solder pumps in the rear of the system. From this simple review, the recirculation of the solder flow is outlined as it returns to the two independent lower pump chambers. These chambers contain no removable baffles, removable flow ducts, or removable vanes used to keep the solder velocity controlled. The pumping stations operate between 260 and 350 RPMs. This in turn pressurizes the lower cavity, and the solder is lifted into the wave hardware, versus a traditional system which pumps the solder into a flow duct. Due to the nature of the entire system, the VS dross management system provides customers with a soldering system that produces considerably less dross, maintains thermal stability between the waves in lead-free environments, and utilizes dross management to prevent dross from entering the lower cavity, which will affect the performance and wave height consistency of traditional systems available.